Hello everyone, this is Udaditya from TechSpot. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. In today's session, we're going to talk about Apache Hive, its key features, and how it helps in reading the data from Hadoop cluster. But before jumping into Hive, we must need to understand why do we need to use Hive? Why cannot we simply read the data from Hadoop itself? Now there are some certain drawbacks if you try to read the data directly from Hadoop. First and foremost thing, in the Hadoop cluster, there would be different file formats. Some are human readable, some are not, such as Parquet, ORC, Avro. Now since these are binary file format, we simply cannot view the file or understand anything. Secondly, reading a huge file for insights is a tedious job. Now, in the world of big data, we will have large volumes of data. In the Hadoop cluster, they will be lying petabytes or even exabyte scale of data. Now, if we simply try to open those files and try to read from the same, this is going to be one hell of a job for us. And thirdly, if we try to read the data, the raw data from the Hadoop without having any SQL-like feature, it's going to be very much difficult to even process or create any sort of insights out of that data. Having an SQL-like feature would be much easier for us to process the data, to aggregate, or even analyze the data in a simpler way. To overcome all these issues, there comes Apache Hive, with its key feature being imparting schema on top of the Hadoop data. It has its architecture, such as the components of the same is integrated with Hadoop, which means the actual data would be lying in the data nodes of the Hadoop cluster as mentioned in the last session. Hive will simply impart a schema on top of it, and that schema will have set of columns and the data types associated with each and every column for us to help us, for us to read the data in a much more efficient way. Secondly, its query processing engine is much like an SQL-like tool. We have used Oracle or MySQL in RDBMS to use the SQL language to read data or analyze the data. It has MapReduce abstraction, which means behind the hood, it will run some MapReduce job. Now, MapReduce used to be a framework that was much used in the world of big data, but now, due to its inconvenient features, it is not being used in the industry anymore. We have Apache Hive and Apache Spark instead of MapReduce. Now, thirdly, the data management, which is much like the Hadoop cluster, is a distributed environment. And the efficiency is much higher when we try to read the data using Hive, as it has some properties such as partitioning and bucketing, which will allow us to scan only the required amount of data we need from the cluster itself. Now, to show you an example how Hive actually works and why am I saying that it has the SQL-like feature, let me just log into the Hive console and show you some of the queries. Now, I'm logged into Hadoop cluster now, and I'm going to open the Hive console. To open the Hive console from Hadoop cluster, we simply need to type Hive and press enter. Now, it will take a bit of time, but the Hive server will be up and running in no moment. So now our Hive server is up and running. Every time we try to open the Hive console, it will have its own session ID. Now, if we try to go to the port 1002, I will see there is one active session. Now, inside the Hive console, I can use the SQL-like language as I just mentioned. Now, if I want to see what are the databases that I have inside the Hive, let's just run a query, show databases. Now, I have two databases over here. One is the data hub, second is the default. Default will always be there when you have the Hive console running. Since I created the data hub for my own purpose, so I'm going to use this one only for the moment. To use any database, we simply write the keyword use, then the database name. Now I am inside this Data Hub database. Let me see what are all the tables that are available for me. To check that, I'm going to run this query show tables, press enter. Now there are two tables that are presented to me. One is the social circle, the second is the social circle underscore part. For the moment, I'm going to be using the social circle table. To read the data from the social circle table, I'm going to use select star query over here, much like any other RDBMS. Select star from table name, and let me put a limit over here as there would be a large number of records. Now once the query finishes, you can see that it has these columns with the values 0, 1, 2, 3, 4, then this wheel, Jean Luke 30, 26, 55, and so on. Now by default, Hive doesn't show the column names. But if I want to see the structure, the schema of the table, I can simply do a DESC formatted followed by the table name. So if I try to describe the table name, I can see there are four columns, one being the serial number, under which the values are 0, 1, 2, 3, 4, then the name, under which the values are Wayne, Will, John, Hugh, Deanna. Then there's age, such as 33, 26, 55, and the number of friends it has, 385, 2, 221, 465, and so on. So this is the schema on top of the data that is residing in the Hadoop. Now, if I talk about the actual data, this is the location of the actual data. So as you can see, it's not a physical table or a database where I'm storing the data. It's actually reading from the data inside the Hadoop cluster. So if I try to validate the same, what I'm going to do, I'm going to get out of here. To get out of the Hive console, just press Ctrl Z. And to look into the data that is lying inside the Hadoop cluster, I will try this command hdfs dfs -ls, then the path. So this is the path from where it is reading the data. So once I list out the files that are inside this path, I can see there is this friends.csv inside this path, and this actually has the data which is being read from the Hive. To validate even further, let me try to read it directly from Hadoop. The read command is hdfs -cat, then the file name. I don't want to read the whole data. I'm going to just read only the first 5 lines of it. So as you can see, inside the file, it is the same data, having the serial number, name, age, number of friends. And if you look at the value 0, 1, 2, 3, then Will, John, 33, 26, and so on. And when I ran the select star query over here, it is reflecting the same data. But reading this way is not an efficient or recommended way. That is why we use Hive to read the data that is lying inside the Hadoop cluster. Even though it's not a huge file, that's why I can read it over here. But in the real big data world, there would be larger volume of data, which will take a long time in doing just a HDFS DFS cat. So this is all about today's session and the discussions about Hive. Stay tuned and reach out to TechSpark to know more. Do you want to learn how to set up Hadoop cluster and Hive in the local environment and get started? Do you also want to learn about Hive optimization such as the partition and bucketing? In TechSpark, we cover all the necessary tools in our data engineering course such as Spark, Hadoop, Hive, AWS with hands-on coding and real-world project. Signing off for now. See you on the next session.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.